here comes the read part. Here things will become a lot more clear. So here's the coordinator. Coordinator says read value some record with a partition key 7, right? So it first tries to get something, this value from an artifact called the row cache. What row cache does is it caches the value of entire row, right? It has the entire data. So if it is there in the row cache, then it says, well, there's a row cache hit. I have the data, so it gives the data back to the coordinator, and voila, easy peasy. But it's quite possible that you try to read from row cache. The coordinator says, hey, try and get the value with partition key 7. The row cache says, nope, I don't have a data, there is a miss. Then what happens is it actually goes to something called the Bloom filter. Bloom filter is an implementation of an algorithm written by some guy named Bloom, an American, in the 1970s. It's a very funny data structure because it can give you an indication whether or not data is there, but when it says no, it's a definite no. But when it says yes, it's a maybe. So that's where things get more interesting. So when Bloom filter says no, you can be absolutely sure that the data is not there. What happens is now the row cache does not have the data. It goes to the Bloom filter, and there is a Bloom filter for each and every SS table over here. So you have SS table 1, 2, and 3, and each one of those have a Bloom filter 1, 2, and 3. So the Bloom filter is going to actually tell whether the data is there in SS table 1, 2, or 3. And this says, hey, does that SS table have partition key 7 and the key cache? And then it says, well, it's actually the first two say maybe, because that's where you get the question mark, that's the one yes, and the last one says no. If it says no, well, then we don't even have to check. But it doesn't actually go and check directly into the SS tables, because as you can imagine, SS tables are going to be massive in terms of volume. What each SS table contains is a key cache. So each SS table, as you can imagine, can have a lot of rows, and each row has got a partition key, and this key cache would contain all the keys in that particular SS table, and it would say, hey, is that well, I should have drawn 3 bits, but you get the idea. So if that particular value is there in that particular SS table, you check in the key cache, and the key cache says, oh, well, yes, there it is, and then you go jump directly into that location, that file, that particular file, which offset, and then you fetch the data, you have a hit. Otherwise, all right, and what then happens is when you get a hit, you get values from these SS tables, and then they are merged with values which are there in the mem table, because there could be values in the memory which are not flushed to SS tables yet. So there is a merge process that goes on with value in the memory, with values in SS table, and that merge value is that one that you see, Elizabeth, last name Blue, level 42, which is then returned to the coordinator. Any questions so far? Or should I go on? Okay, no more questions, so I'm going to go on. Now, same old story. You're going to try and read from the row cache. Row cache says no, and then you go and try and hit Bloom filter. Bloom filter says maybe, maybe, nah. You don't go and check the third one, and this one says, well, I don't have that data, because if this key cache does not, key cache is again a cache of all the keys. If that key is not there in the key cache, well, maybe it's not there, or maybe it is there. So then you have something called a partition summary. Think of it as an index of an index. So what partition summary does, as you can imagine, these SS tables have got a lot of keys, and each partition is there in a really long index. Let's say it has an index of 1 to 1000, and then the partition summary will say, hey, you can go within this partition index to this particular location. So it's like an index of index, you know. So this is an index of this index, and this index will give you the location in this particular file. So once it does retrieve the value from the partition summary to the partition index, then what you do is then, hey, you know now that this particular SS table has this particular data. If it does, then you populate the key cache saying that this particular key is there in the SS table, and you don't just then you retrieve the value from those SS tables, perform a merge operation with the one in what is it called, with the one in mem table, and that that value is also updated in the row cache, and then you return the value to the coordinator. Clear? And now you see why read is a lot more complicated than write. So performance is massive. Well, the performance penalty is massive in terms of reads when it comes to Cassandra, but writes are blazingly fast. So imagine if you want to have some of the neat applications that we try and use, or for event logs or something like weather station. You just want to record data. You're just throwing in data a lot more faster compared to that of reading in data. So if you're writing data more quickly and then reading it less frequently, Cassandra is an ideal candidate because writes are 10 times faster than read, up to 10 times.
The result also replicated to all the nodes?
Sorry?
The result also replicated to all the nodes?
That's where the consistency level comes into play. It happens behind the scenes. You can choose what consistency level you want, and then you pay the price for it. Yeah? So they leave it up to you. They won't solve the problem for you, bastards. Yeah.
Also, if you read, so you read the first time, it gets cached. So
Mm-hmm.
if you read again later on other clients, it gets better.
Very good question. Row cache is an optional component. It's not enabled by default. The reason why it's not enabled by default is because, well, row caches are there in the RAM, in your physical memory, but Cassandra has its own cache. Cassandra is a Java product, so it has its own cache. And then the operating system also caches the row, and then it has its cache. So then what guys in Cassandra found out that if you have the row cache enabled, sometimes you have data that is cached twice by the operating system and also by Cassandra. So that's why they left it optional. You can turn it on or you can turn it off. But I just wanted to show with the scenario that the row cache is enabled so that you get the entire flow. But there are use cases where you want to keep the row cache enabled. And one such use case is where you have something called the master data, when you have a limited amount of data, which is not too much in number, and you want to keep that data. Let's say all the postcodes mapping, the country has a limited number of postcodes. You want to probably keep all the postcodes in the memory, and that can be kept in the row cache. But if you have a massive amount of data that just keeps changing all the time, you probably don't want to enable row cache. Huh? Move on. Well, there is something called tombstones. This, we wrote data, we read data, then comes what? Deletion. What happens when you delete data is that you're not actually deleting data. Cassandra just puts a marker saying that, okay, we're going to delete data, and that data is marked for deletion. That is called tombstone. And when you actually do compaction, that data is checked whether, hey, is the GC grace period in seconds, which is GC grace period is just garbage collection grace period, which means you mark this row as deleted or you put a tombstone on it, but you have some time in seconds when you still want to have that marker in place, and then after that time passes, you just delete it, or you just, during compaction, you don't write it. So the way Cassandra does deletion is not actually deleting it, but when compaction takes place, it doesn't do a write, it avoids a write behind the scenes. And then we have zombies. Well, the funny thing about zombies is that let's take the case of a cluster with 3 nodes, right, which is the default for sake of simplicity. And in that cluster, there are 2 nodes, and the 3rd node goes down. And then you mark some items for deletion, and then after GC grace period in seconds, let's say I put the value 60 seconds, and after 1 minute data is actually deleted during compaction. And then the compaction takes place, and when the compaction takes place, the data is not written to the big SS table. And then after some time, the network administrator finds out, hey, node 3 is down. Let's bring the node 3 up back again, and then they bring the node 3 up. When node 3 comes back up, it sees, hey, wait a minute, I have some data which you two guys don't have. So what I'm going to do is I'm going to give you the data so that you can replicate in your data set. And then the bugger you thought you deleted comes back live again. And that's why they're called zombies, because you thought they were dead, but they came back alive. And the way to actually kill these zombies, quite important if you watch horror movies. Huh? No, you can't kill zombies. They keep coming over. Okay. So you use a tool called a node repair tool, and that is going to restore the failed nodes. Or another approach is to actually wipe off that node completely and then bring it back in. It's a cold start, and then the other nodes which are alive will replicate data. That is why you have to know the value of GC grace period in seconds. And if your node is going to be dead for more than that, GC grace period in seconds, then don't don't bring it up. Do a cold start or do a node repair. Very, very important operations. So yeah.
Is there any monitoring tool that tracks this zombie code so that it brings the node down?
Op Center, Operation Center. It's a free tool. And there's also node tool. We're going to go and see a few screens where Ops Center is a UI tool which is quite fancy, and the node tool is good old-fashioned command line or terminal tool. Yeah. Right. Now we go. I think it's time that we can take a break. Or hold on, let me check quick. Okay, few more slides and we take a break. Yeah. Cassandra query language is the language where you use to write queries in Cassandra. It's called SQL. Very funny abbreviation. Then because people start to get confused. Hey, are you talking SQL or CQL? Yeah, and it's also written SQL. And the other funny bit is that they are so similar. They are written so similar because they wanted people to embrace Cassandra and start using it right away. But then behind the scenes, a lot of things are quite different. That is why I call it a double-edged sword, because it gives you the benefit in terms of familiarity, but then sometimes not being familiar is also a good thing. You'll see why.